we're looking more or less about the graphs, the equations, things like that. We're not like worrying about inside, outside, on. You're not looking at segments that intersect on the interior of a circle. They're not worrying about the segments on the outside. I think Seb had that great circle packet, which you still have. That's awesome. You still have this. We don't get into that stuff here, really. But what we will be worrying about, we will be working with, is going to be the equations. And to start with the equation parts of circles, we're going to center everything at the origin today. I know that last year in section 10.7 in the geometry book, you guys moved the circles around. Whether you're in my class or in Seb's class, you wrote a couple of equations of circles in terms of H and K. You just didn't realize that those are the H and Ks that you're going to be seeing again this year. Yes, ma'am. And it's fine. You may or may not have, and it's okay. Because it's actually really, really, really easy. So, we know circles to be, come on guys. We know circles to be a set of points that are all equidistant from a center. That's all a circle is. Okay? Each circle has something called a radius.
Really?
Yes. That radius.
This is totally off topic. Have you ever had crunchy gum?
No, that means I didn't brush my teeth and there's stuff in my teeth and my gum is crunchy.
No, Aaron's crunchy gum.
Try it. You know last year we had to try all the gum.
Oh yeah, you guys had good gum.
Try this. It's crunchy gum. Just try it.
No, last year they had, what was that gum you had last year?
It was the Trident. It was the grape lemonade.
Oh, that sounds so good. Grape lemonade Trident is like the bomb.
It's a triple layer gum. That's so good.
So this is chewy gum.
It's crunchy.
It's weird. It's like crunchy. All the gum is chewy. It's confusing.
I like it. Isn't it weird?
Yeah. And it's like the flavor's already gone. Yeah, it feels like I have bad breath already.
Maybe you already have it.
When you get F on the next one, we'll all know why. Jory.
Mr. Murphy, do you need a raise?
Jory, you gotta make it 2 now.
So, well done. So today we're going to look at the standard form of the equation of a circle. It's going to be really simple. X squared plus y squared is r squared. We are going to center our circles at the origin, which means by the end of, well, we're not going to start shifting and moving these things around until next week. So what I decided again is that your new textbook gives everything at you right away with all the different shifts and all the different parts and all the different pieces, whereas I think it's easier to understand what things mean first. What are the relationships between the radius and the center, how you can write these equations, because we're going to write equations of lines that are tangent, blah, blah, blah. It's easier to start with it when it's centered at the origin because there's nice patterns that are formed. Next week, we'll switch it into this, which is what you probably saw last year. Where that's the center of the circle. Okay. Now, again, if you did see it, great. If you didn't, it's not the end of the world because it's really easy. Okay, circles are one of the easier conics to deal with in a roundabout way. Thanks.
That's a negative.
So, if this is the case, and we say our radius is 4, if my radius is 4, and my equation my circle is centered at the origin, it would just be the following: x squared plus y squared equals 4 squared otherwise known as 16. And that's the equation of a circle in standard form with a radius of 4. That's it.
Are you okay?
You all right? Crunchy gum trying to kill you?
Okay.
You know when old ladies like laugh and they start coughing?
Anyway, so listen. Not really well. I'll show you how it works because the resolutions for the graphs, our graphing calculators are more of a stretch. They're not going to show a really nice round curve to it. But I'll show us in a minute when we write equations here how we can find intercepts and stuff like that as well. All right. So today everything's centered at the origin. Everything's at the origin. We have radii. Next week we'll start shifting things around. So let's graph the equation of a circle. We have the following equation: y squared equals 25 minus x squared. Yes, ma'am.
For the x squared, r is y squared, what would those vectors, like the values of r squared?
We don't know.
Like, what
Because
would they
it's
represent?
what happens here. What happens here is that eventually our circle is going to be out in somewhere in space. It'll be at, the center will be at 3, 4. The equation then would be x minus 3 quantity squared plus y minus 4 quantity squared. Let's say this had a radius of 2, so it's equals 4. So what this is going to be able to do is that's what the standard form of the equation of the conic looks like when you put it in standard form. At some point in time, you're going to have something completely fully factored out that you're going to have to decide what conic is it. And then we're going to be able to take stuff that looks like I'll be able to take something that looks like this. And by doing a bunch of math, all conic sections have basic properties. And what we'll be able to do is group and be able to move stuff around. That's kind of where we're headed towards. It is. It's a good question. It's just we're looking at the factored form. Eventually, we'll start with just standard, which is just it's not standard form, but what it's called this form, and we're going to figure out in terms of standard, because the conics, there's 4 of them: parabolas, circles, ellipses, and hyperbolas. Since this has an x squared and a y squared, it's not a parabola. Parabolas are only x squared or y squared. By doing a couple of steps, complete the square, you'll be able to figure the rest out. But anyway, back to this. Draw the circle given by the following equation. Now, the standard form of the circle today is just going to be x squared plus y squared is r squared.
Did you get a marker?
I think Lost House left it in here. So that means I have to get and move that minus x squared. How do you move a minus x squared?
Add an x squared.
You add the x squared to both sides. You get x squared plus y squared equals 25. Which means, where's your origin? Where's your center? 0, 0.
Because that's what we do.
Today, everything will be at the center. And the radius is 5. So in order to graph a circle, this is really difficult. We start at the center, and you go out 5, up 5, left 5, down 5. And then you draw a circle. That's it. Yeah, not drawing the scale.
That was saying something. Why not?
And that's okay. They don't have to be perfect, guys. This is what they're supposed to look like. The other portion of this stuff. The other portion of this stuff, when it comes down, is not always are your radii going to be clean.
Oh, man. Oh, crap, that's
Great.
beautiful.
In this case here, your r squared is 32, which means what's your radius?
In between 5 and
Good. What is it?
Yeah.
Two
No,
square
no,
root.
2 square root.
Maybe 2 square root.
8. Hold on. And you can go further than that, though. Because you have an 8 that you can take care of. What's the largest perfect square that goes into 32?
4. 5.
4
roots.
Wait.
Two?
Four roots, that's the one.
32.
Hey, guys. Guys, hold on.
Because it can.
Did you hear what you just said?
No. 16 by 2 and then it's 16
Oh,
and
there you
2.
go.
Double.
We're all
So,
good.
real fast, just so everybody's aware that you have this really nice machine that will allow you to kind of figure all this stuff out. I don't know why I'm talking over you. This is ridiculous. You guys ask about what the calculator can use. I don't know what to do with my calculator. I don't know what to do with my calculator. Well, here's a thing that if you can't simplify a radical, this is what it'll help you do. 32 divided by x squared. Go to your table. You're looking for a value in the y column that is an integer along with the x column being an integer before everything goes to all zeros. That means when x is squared, y is this. So when we took what? 32? 32 divided by 2 squared is 8. 32 divided by 3 squared is 3 and change. 32 divided by 4 squared is 2. So that means your answer here is 4 root is the radius. Okay? Now, what's going to happen a lot now with conics is that you're going to have a lot of square roots. And you have to be able to approximate a square root on a graph. Now, you were saying a second ago that the square root of 32 is between what two perfect squares?
25.
Between 25 and 36. We know that the square root of 25 is smaller than the square root of 32, but that's smaller than the square root of 36. Is 32 closer to 36 or 25? 36. Is it more than halfway, you think? Do you look at your distances here? Here's this distance is 7, this one is 4. So it's a lot closer. So maybe 5.6-ish. It just kind of, you're guesstimating. So what's going to happen is when you start to plot these things out, you're going to put it closer to 6 than you would closer to 5. That's it. And the reason that we have to be able to do these approximations when we're plotting these things into our graphs is because when we get into working with the ellipses and with the hyperbolas later on this week, when we have an ellipse is going to be either vertical or horizontal. If my center is here, then I'm going to have certain distance to my vertex, certain distance to my focus. I'm going to have a specific distance to my co-vertex on both sides here. It's all dependent upon these values. Thank you. Remember how you guys were asking me when we did parabolas, why do I draw things that have little curve to them? Because it's easier to visualize where everything's going to go. A lot of these points in here are going to have square root value to them. So we're going to have to be able to adjust ordered pairs via square roots. So we have to know approximations. So knowing how that the square root of 32 is between 25 and 36 is good. Okay? Yes, ma'am.
Wait, so for the radius, you want to write 4 square root 2?
Yes.
Okay.
Yeah. You always simplify. Whenever it asks for a radius, anything that you take a square root of, you always use simplified radical form. Okay? So then it's just a matter of, and there's sort of, it's close. Okay? You can just kind of assume that's all of these. The point 1,4 is on a circle whose center is at the origin. Write the equation of the circle in standard form. Well, circle in standard form at the origin, which is what we're worrying about today, is always going to be this. X squared plus y squared is r squared. And again, you guys are going to start to like these style problems because you do all of them the same way. There's no variance to it. There's nothing you have to try to come up with on your own. I know. The hardest part is knowing where is 1, 4 on the graph. 1, it's right there. Now, if that point is on the circle, means it's got to go around here, ish. And the radius would be from the origin to this point. Do you agree on that? So, do you want to use distance formula or do you just want to count? Count. You can use the distance formula all you want.
Couldn't you plug in the x squared plus y squared equals r squared too? That's the center.
Isn't this the right triangle? Isn't the change in x value your horizontal change? Which is 1. What's 1 squared? What's 4 squared? Yeah, and that happens a lot. Okay. Now, what's going to happen when we start moving things around, though, when you're not centered at the origin, things can get a little bit different. And that's when you can use the distance formula, or, like I was saying, is that once you start realizing that if my center is here, and that's my radius, and I know these 2 points, can I just count how far over this is, and then how far up that is? Isn't that, in essence, just the distance formula anyway? It's easier. You can use distance formula all you want, but distance formula really is just Pythagorean theorem, just counting. All right. Yes, sir. 1 squared plus 4 squared. And yes, it is quite literal that. All right. It's quite literally that.
Wait, so then the radius.
Is it a pen or a pencil?
It's a pen.
So then
What'd you get?
I got a Dave and Buster's.
I don't want to go there. That's too far away. All right. So the equation then, your final equation, your answer would be that's it. Because standard form has it written as r squared. You have to take the square root of it. It is. For 17? It's probably less than that because 17 is only 1 off of 16. So it's probably 4-1. 4-1-5 or something. You mean it's close-ish. Okay. Yeah, I stayed up all night fixing it. Write the equation of the line that passes through those 2 points, or not the equation line. Write the equation of the circle that passes through those 2 points, please. Super quick. What is it? I look like him now?
Yes, that's it.
Oh, that's right.
Yeah.
I feel like I can mow my lawn, get some gloves and a hat. Yes, ma'am.
I faked the doctor. She's like, hey, Anna, can I see your Chromebook? But your Chromebook's on your desk. You know?
No, not Hannah.
Oh, I doubt Ray's so good.
Look at her. Sticky fingers McGee.
What? Yeah. That's kind of how she acts every day. And because you're going to steal my things.
Why would I steal your things when I have my own?
Because my things are better. So you want my stuff.
So, just a quick reminder, you guys remember these things in math called triples?
Yes.
I wish I forgot that.
You make your geometry teacher so proud.
Because I was like going through and I was like, oh, this is a triple, so
And was it a 3, 4, 5 triple that showed up?
yeah.
3, 4, 5 triples show up all the time. 5, 12, 13 is another triple. 7, 24, 25. 8, 15, 17. Was it 9, 40, 41? Here's the other one. Anyway, what I'm looking at here, guys, is that when you're given just, you know that everything's at the origin. It's just x squared plus y squared is r squared. What's negative 8 squared? What's 6 squared? So what's your r squared? And that's, what's the equation for standard form? And I'm glad you made that mistake, because you don't. You're done. It's x squared, y squared is 100. And you're done. Okay? Don't square root it, guys. Don't square root it, okay?
So is this gonna be our homework?
Sure. But wait, there's more.
Ew,
Tangent lines. So let's discuss, this is actually a pretty big topic. This is a pretty big topic that we introduce you guys to in Algebra 2. We do more of it in pre-calc with what's called average rate of change, which gets you into calculus with derivatives. Slopes and tangent lines are a big thing in calculus because they're all come from these little baby steps as we progress through. So what I'm talking about here is finding the equation, find the tangent line. Now, if you guys recall from your big circle stuff from last year, if a line is tangent to a circle, how many places does it touch the circle? One. And what makes it tangent is that it is then what to the radius?
Perpendicular.
It's perpendicular to a radius. Good. So if it touches the circle at one spot, it's going to be perpendicular to a radius. Now, in this case, then, we have to remember a couple of things about what tangency means. Being perpendicular means that you form a right angle. If something's perpendicular, if two lines are perpendicular, they have something about their slopes. What do we know about perpendicular slopes? Very good. They're opposite reciprocals of one another. Perpendicular lines that are perpendicular to one another have opposite reciprocal slopes. So if my original slope, for example, if my original slope is 3, very good. Perpendicular to that would be negative 1/3. If my original slope is, see if you remember this one. What is it?
No.
No?
It's 0.
Nope.
It's negative 0.
No such thing. Yes, sir.
There is none. Because you can't go like,
It's like,
you can't do like
x equals 0.
Like,
Yeah, there is.
Parallel.
You can't do
Imaginary 0.
You can't do negative.
I'm thinking about that right now. No such thing.
You can't do negative 1 over.
All right, how about this? Let's rephrase this. What kind of lines have a slope of 0? Don't say straight.
Horizontal.
Horizontal, because horizontal lines, what's the second letter in the word horizontal?
0.
Exactly.
0 is the
Horizontal line.
Close enough.
Horizontal lines.
Horizontal. 0.
Your slope is 0. The equation of every single horizontal line is always y equals some number. Well, what kind of lines are perpendicular to horizontal lines? X equals a number, which means it is a vertical. So vertical lines,
It's like
well, that means your slope is undefined. Vertical lines have undefined slopes. 0 and undefined are opposite reciprocals of one another. Because if 0 is a slope, it's 0 over 1. Flip it, you get 1 over 0. Can you divide by 0?
No.
That's why it's undefined.
No.
Okay? And the vertical lines are always x equals a number. Just a little refresher from lines and equations from back in the day. You'd be surprised at how often this stuff comes up. Okay? So back to this one. If my original slope was 0, my perpendicular slope would therefore be undefined. But not always are we going to have zeros and undefined slopes within tangent lines of circles. It's always going to be dependent upon the point in space that they pick. Now, today, like we've been saying, is that our center of the circles are always going to be at the origin, so it can be really nice. But if I got to figure out what this is here to find the slope, well, how do you find the slope within the set of 2 points?
2 over minus x.
Slope is rise over run, correct?
Yeah.
Change in y over change in x.
Yeah, so this is the x2 minus x1 over y2 minus y. Or no, the flipped. But
Right. So yeah, this is your change in y over the change in x. Today it's really, really easy because what is one of your ordered pairs always going to be? 0, 0. So all I have to do here for today, if this ordered pair is at 3, 4, what's your slope of the radius?
-1.
Huh? If my, just for example, slope of the radius here, change in y over change in x, well, what's 4 minus 0?
4.
What's 3 minus 0? What's 4 over 3? What would be the perpendicular slope to 4/3? Okay. And that's kind of the steps that we would start to work ourselves through. Okay? But let me get to a problem that actually I know that works cleaner because I don't have the, well, we could go from here. If I know the, no, I'm not going to. I'm going to do this twice. If I know what my slope is, and I know what the point is, what form of the equation then could I write? Knowing a point and the slope. Point slope form. Point slope form then is what you would use. Did you know that point slope form is just h and k? Horizontal shift, vertical shift from you going through the origin. That's all it is.
Wait, what form is that?
Point slope form.
Okay.
So when you use point slope form, you're going to use your point, obviously. Y minus 4 equals your slope, negative 3/4 times x minus 3. And for every one of these, all you're going to do is distribute and resolve for y. Yes, this is relatively simple because you've all taken algebra. And you did this all last year again in geometry, writing equations of lines. Writing equations of lines and things like that are things that don't go away. So this should be easy. Yeah.
Wait, was this our question was I gonna ask you to write it?
Yeah, write the slope-intercept form. So at this point then, I have the equation of the line. Well, I got to add the 4. Another little short trick to remind you guys. If I add 4 here, I add 4 here, but I'm adding 9/4 to a 4. When you add fractions, you have to have common denominator. Same thing as 16 over 4. If you don't remember how to do that, your calculator will. Alpha, y equals 9 over 4 plus 4. It'll do it for you. Okay? Here's the equation of the line that is tangent to the circle that's centered at the origin at the point 3-4 or 4-3, excuse me. Okay. Let's go through that again. Okay. Oh wait a second. Hmm? The process for these things don't change, guys. Find the slope of the radius, get the reciprocal slope, use point slope form, and solve for y. It's the same thing every time. Whether or not you're centered in space or you're centered at the origin, these are all going to be the same. Okay. Let's try another one. Find the equation of the line that is tangent to the circle, x squared plus y squared equals 13 at the point 2, 3. Yeah.
Can I ask you one quick question about this gradient?
Oh, yeah.
So then, you originally the 4/3, was that this?
Yes.
Okay.
Yeah, because the original one was just the original slope here is just 4/3.
So the 4/3 was the tangent line.
No, the 4/3 is the radius slope. Because we had the point here was at, this was at, I just made up whatever, 3 or 4. This one was change y is just 1. Always. It's easy. You guys, I know that you guys can write equations of lines straight into slope-intercept form by solving for b if you want. Personally, I don't think that's very efficient. I think by using point slope form always, it's going to force it into that slope-intercept right away. You're less likely to screw something up. That's just my own opinion. So again, when we start problems like this, we have a circle centered at the origin. We're at the point 2, 3. We have a radius that is going to be the square root of 13. The square root of 13 is a little bit more than 3, but a little bit less than 4. So it's between, wow, that's really not drawn to scale. Anyway. And there's our point. We want to do tangent. So that's what we're trying to solve for. Very first thing you do is find the slope of your radius. Slope of the radius. Well, since we're centered at the origin, it's always just going to be y over x. Always, 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 y over x. Okay? Why the scrunchy face? So your slope, since it's at the origin, when we change y or change in x, so it's just y over x. Now what's perpendicular to a 3/2? -2 over 3. So perpendicular slope then is -2 over 3. So we'll use that slope with that point. Distribute and solve for y.
What's slope rad?
What's that? Oh, slope of the radius.
Oh, okay. Oh.
Have you figured out my chicken scratch yet? It's almost November.
I thought it said no, Brad, and I was like, what is
Yeah,
that?
that's what it says.
That's what I was looking
I
at.
was so confused.
It's the most rat of the sea.
Just stop. I'm ready to go.
Add 3.
Wait, but where are you getting the 4?
What for?
4 plus 4.
There's no 4. There's a 4 on top of
I'm distributing. -2/3 times -2. is positive 4/3? And then I just add the 3 over. When I add 3 over, it's just 3 over 1. But if I want to put it as a denominator of 3, it becomes 9 over 3. Or I put it in my calculator, and I get the following answer. I get 2/3 x plus 13/3. Okay? Now, one of the things that's nice about the graphing calculator is that you can always check your work. Okay? Now, your graphing calculator will at least find the intersection point. It might not tell you what the values themselves work out to be. Because you didn't do your work. I asked you to do 2 columns, and I can't stay around and quit to pick up my son, so I'll talk to you tomorrow. So when we do these things, let me show you this little trick. We have 2 equations. We have x squared, y squared is 13, and then we have y equals, what was it, negative 2/3. Okay. Now your calculator has a button in the upper left-hand corner that says y equals. So if I want to get y by itself here, what do you move first? Subtract the x squared. And I get that. How do you undo squaring them? Square root. When you take a square root over an equal sign, what do you have to do? Plus minus. Yes, we can. But the thing is that there is no plus minus button on here. There's no way for me to do just plus minus the square root, which means I have to write out a positive square root and a negative square root. So let's do this. Second square root 13 minus x squared. And then we do a negative square root 13 minus x squared. And then we put in our tangent line. Alpha y equals fraction bar negative 2/3. Thank you. Thank you, ma'am. And then we have an x, and then we add another alpha y equals fraction bar. And with any luck, it should show up, because I don't think I picked anything that looks so. It doesn't because of the resolution. If you think of, it doesn't even look like it's a full circle. It looks like it's more of an ellipse. It's just because the way that the formatting is on the calculator screen itself. It's not like a true, 16 by 9 or whatever you want to call it for how those things work themselves out. So, with any luck, the point that we figure out that these two graphs, the point where these two hit should be at 2, 3, shouldn't it? If you hit your button on the calculator, it says second calculate. I'm looking for the intersection. Now, what's really nice about this graphing calculator is that it tells you first curve in blue. We want the first curve in blue, so we would hit enter. The second curve, we don't want it in red, so we hit the up button, and that's how it switches graphs until it gets to the black one. Yes? I don't know.
Can you go back to where you plug it in?
Why is this not working? Oh, I just did it. Yep. So it's at 2, 3. It'll fetch it. It'll be up. It's I gotta post it.
Can you go back to the white again?
Yeah. It will be in a second. Otherwise. Just wait. Well, another way for you guys to check your work. If you did it right, you can come up and calculate, and they'll see if it comes up to the points. Obviously, here it said what 2.999, and the other one was 2.999, or 2.0, excuse me, and then the other one's 3. So, this is old book.
I have an error again.
Give me 1 second, you probably have something in your table. Get those through for tomorrow. It's going to come out straight lines because the window's probably so obscured right now. So when it, just always go back to your
Wait, that's true.
do it 10 by 10.
No, I said, because Mrs. Sparrow wasn't there. I started to. Mr.
Yours is saying arguments are entered. No, your arguments are wrong. So your,
I'm not gonna do it.
yeah, when it says arguments, that means you used the minus, not a negative symbol.